Welcome to this video in the Understanding Energy series, where we take a closer look at the cornerstones of our energy system. Today, we're focusing on the three main non-renewable energy sources that power our world. Whether you're a student, a professional in the energy sector, or simply curious about how our world is powered, this video is tailored for you. Let's dive in and explore these crucial energy sources together. All life on Earth is sustained by energy. Humans extract this vital force from food to maintain life and utilize different energy types to regulate our temperature and facilitate movement. The sun is the primary source of this energy. It nourishes plants, which, through photosynthesis, convert solar energy into growth. Fossil fuels, like the gasoline in our vehicles, are ancient deposits of this solar energy, originally harnessed by flora and fauna eons ago. When these organisms perished, their biomass retained a portion of the sun's energy, eventually transforming into the fuel sources we depend on today. Energy exists in numerous forms. Yet fundamentally, it is classified into two primary types: kinetic and potential energy. Kinetic energy pertains to the energy that an object possesses due to its motion. For instance, radiant energy is the energy of electromagnetic waves, encompassing light, X-rays, and radio waves, with sunlight being a prime example. Thermal energy results from the motion or vibration of molecules within a substance, similar to the warmth from Earth's geothermal layers. Motion energy describes the energy of objects in transit, such as the energy harnessed from moving air, known as wind energy. Potential energy, in contrast, is the energy held in reserve. Examples include chemical energy, stored within atomic bonds, as seen in fossil fuels like oil and coal, as well as in biomass like plant material. Gravitational energy, which is energy due to an object's position relative to gravitational forces, like water stored high in a dam. Nuclear energy, contained within the cores of atoms, is liberated during nuclear reactions, such as fission or fusion. The majority of Earth's energy consumption is derived from the three primary fossil fuels: oil, coal, and natural gas, which combine to provide 80% of the global energy supply in 2021. These fossil fuels originate from the decomposed remains of ancient plants and animals. Over millions of years, these remains were compressed under layers of Earth, transforming into coal, oil, and natural gas due to intense heat and pressure. Fossil fuels are rich in carbon, an element naturally found in the environment, making them a potent source of energy. Coal, notably, was instrumental in fueling the Industrial Revolution in late 18th century Great Britain, significantly advancing mechanization over manual and animal labor. However, burning fossil fuels for energy releases carbon dioxide, CO2, into the atmosphere. Over the last 2 centuries, especially since the 20th century, the accumulation of CO2 emissions has led to global warming. This phenomenon is linked to various environmental crises, including the melting of polar ice caps, the disruption of agricultural patterns, and the heightened occurrence of extreme weather events. Coal, a widely used yet inexpensive and plentiful energy source, is heavily relied upon by countries like China, which leads in constructing vast coal-fired power stations. However, coal ranks as one of the most polluting fuels, emitting more CO2 per electricity unit compared to oil or natural gas. Innovations in carbon capture and storage, CCS, technologies present potential solutions for mitigating coal's environmental impact. Through CCS, CO2 produced during coal combustion is captured and then sequestered deep underground, such as in depleted oil fields or rock formations. This method is already applied in enhancing oil recovery, with approximately 38.5 million tons of CO2 injected annually into U.S. oil wells to extract residual oil. Advanced coal-fired power plants equipped with CCS could potentially trap up to 95% of coal's carbon emissions, significantly curtailing its environmental footprint. Oil has profoundly transformed the global landscape as a pivotal energy source, fueling vehicles, powering flights, and serving as a primary electricity source for numerous countries. Beyond its role in energy, Oil is a crucial component in producing a vast array of products, including plastics, paints, fertilizers, fabrics, and cosmetics. Typically extracted from high-pressure underground wells through drilling. Oil extraction methods vary, employing pumps or injecting substances to bring oil to the surface in low-pressure areas. The industry has evolved, employing advanced technologies to drill in challenging environments, such as offshore platforms for deep-sea oil. Regarded as black gold for its immense value. Oil's geographical concentration, especially in the Middle East, has spurred geopolitical conflicts over resource control. Environmental and wildlife conservation concerns have also emerged, particularly with contentious proposals like drilling in Alaska's Arctic National Wildlife Refuge. As conventional oil reserves dwindle, the industry is turning to innovative technologies to tap unconventional sources, like extracting oil from tar sands. This process involves separating bitumen from sands, a complex, costly procedure, before it can be refined and used as oil. Alberta, Canada, stands out in tar sand exploitation, producing approximately 1 million barrels daily, highlighting the ongoing quest to sustain oil availability amidst depleting resources. Natural gas ranks among the world's primary fossil fuels, with its usage surging in recent years due to its cleaner combustion compared to coal and oil, resulting in fewer emissions for equivalent energy outputs. Utilized for electricity generation and as a direct fuel source for heating and cooking in residential and industrial settings. Natural gas offers high-quality, immediate energy. However, its highly flammable nature demands stringent safety measures for storage and appliance use to prevent explosions. Found typically underground, often near oil reserves. Natural gas is frequently flared during oil extraction, contributing significantly to global warming and squandering an estimated 140 billion cubic meters annually due to the challenges and costs of capture and transport. A viable solution is converting natural gas into liquefied natural gas, LNG, by cooling it to approximately -162°C. Creating a highly concentrated energy form that is more manageable to ship, occupying 600 times less volume than in its gaseous state. This process enables the transport of natural gas from remote areas to needed markets. As of 2023, approximately 480 LNG terminals operate globally, with imported LNG being regasified upon arrival. In this video, we delved into the three primary non-renewable energy sources. If you found this content helpful or have any thoughts to share, please drop a comment below. Don't forget to subscribe to our channel for more enlightening discussions on energy. Keep an eye out for our upcoming videos in the Understanding Energy series.